Morning, 6th grade. Happy Wednesday. Lesson 48. Done with the quiz on the backside. I have been reminded this week, remember, we do our practice examples down on this backside too. So get your practice in of doing those problems with me that I'm going to put on the board. You're doing them here. The more times we can get the repetitions in our brain, the better they'll be for us. I'm going to read down the columns, check to see if you agree with me. If you don't agree with me, you circle it. So, for example, I say the first one, 0.8 plus 0.4 is 12. You're going to go, that's not right, Mr. Bauer. Circle it, because it's supposed to be 1.2. All right, so the first one is 12. Add the next one, 1.6, 6.3, 5.2. Subtraction, line up your decimals. 0.4, 0.8, 5.7, 0. Multiplication, I multiply and then slide decimal the number of decimal places. 0.32, 0.48, 1.8, 0.09. For the first three, it's over, up. Whatever you do on the outside, you do on the inside. For the last one, you don't have to do anything. Just go straight up. So I divide, I get 2. I divide again, I get 3. I divide again, I get 20. I divide again, I get 0.03. So check those answers. Circle any ones you and I disagree on. The mental math from the section A through H goes like this. I multiplied, I got $245. I divided, it slides it left once, 1.275. Easiest way to do C was reduce 6/4 to 3 over 2. Times 3 gives me 6. D is math, guys. It's not yesterday's lesson working with exponents because the bases are different. So you just have to do 10 squared, which is 100. You have to do 5 squared, which is 25. 100 divided by 25 is 4. Estimate, first one becomes 6, second one becomes 4. 6 times 4 is 24. Divide by 8 is 10 times 3 is 30. Find the range, biggest number, 99, smallest number, 29, subtract them, 70. 10 times 8 is 80, plus 1, 81, square root 9, plus 2, 11, times 4, 44, minus 2, 42, divide by 6 is 7, times 9 is 63, plus 1, 64, square root 8, divide by 2, 4, divide by 2, 2, divide by 2, 1. The teacher asked for 2 or 3 volunteers. Adam, Blanca, Chad, and Danielle all raised their hands. From these 4 students, how many possible combinations of 2 students could the teacher select? How many different combinations of 3 students could the teacher select? So they're teaching you how to do combinations, guys. That one's a little bit different than permutations. Permutations is just, hey, there's 4 students. I'm going to go 4 times 3 times 2 times 1. That is if I'm using all the students. Here I'm not. I only want 2 of the 4 students. So guys, with this one, it's just come up with a pattern to do that. So here's what I did. If you notice, the students had the first letters, A, B, C, D, which makes it kind of nice for us because then I can just use their initials. So I started with A. A could go with B, A could go with C, or A could go with D. Those are the 3 combinations A can go with. Now I switch to B. But guys, B already went with A, so I don't do 3 sets of 3 here. So B already went with A here, so the only thing B can do is go with C, and then B can go with D. C had already done A up here, C had already done B here, so C can only go with D. So 3, 2, 1 gives me a total of 6 combinations of 2 students. Now we go to 3 students. A, B, C, then A, B, D, and then A. So first I missed the D, then I missed the C, then I missed the B is the easiest way to explain that one. Then I got to get rid of the A, and I have B, C, D. So when we want 3 students, there's only 4 combinations of those. All right, they're going to give you one of these coming up on one of your power-up tests where they ask you to sort games. How many teams can I play? Okay, notice if A plays B, I don't switch around and do B and A here. They've already played each other. With combinations, the order doesn't matter, so I don't put it back in there a second time. So keep that in mind for the future when we do those things. Okay? Quick review from yesterday. Remember powers of 10. When I multiply them, I just add the exponents. When I divide them, I subtract the exponents. Power to a power, multiply the exponents. When I'm multiplying, number of times to the right. When I'm dividing, number of times to the left. Today we're going to get a review lesson on fractions, decimals, percents, equivalents, which just means you got to be able to switch to all of them. I can give you a fraction, make it a decimal, percent. I can give you a percent, make it a fraction or a decimal. I can give you a boom. We do them all. Okay? Hopefully you have your yellow folder sitting there to be able to fill into a few blanks as we go through it. You got absolutely barely anything to say. It just says this. We may describe parts of a whole as a fraction, decimal, or percent. This is 1/2 of a shaded circle, which is 0.5, which is 50%. Recall that when we name a fraction, we multiply it by a form of 1, such as 2 over 2, 5 over 5, 100 over 100. Another form of 1 is 100%. So to convert a fraction or a decimal to a percent, we simply multiply it by 100%. Okay, those of you who are loving your yellow folder and realize it's a great resource that I should be using all the time, I'm just going to fill in the blanks. How do I switch a fraction to a decimal? That's division, guys. Top number in, bottom number out. Okay, so just write the word division. How do I switch a decimal to a percent? Move it right twice. Therefore, how do you switch a percent to a decimal? You move it left twice. How do I switch a percent to a fraction? The percent means over 100. So percent over 100 and reduce it down. How do you switch fraction percent? Times it by 100 over 1. How do you switch a decimal to a fraction? The decimal number's on top. The place value is, 2 minutes please. The place value's on the bottom, okay? And then you reduce those down. Helpful hint, extra credit on your worksheet. Which fractions and decimals can be reduced? Ones that end in 0, 2, 4, 6, 8, and 5. Okay? So if it's, guys, if you have 37%, I can't reduce it. That ends in a 7. So 1, 3, 7, and 9 can't be reduced by 100. So little helpful hint, just right on the top, 0, 2, 4, 5, 6, 8 can be reduced. Boom, you added a helpful hint that makes it a little easier for you. You got yourself a little extra credit. Speaking of extra credit, as we go with the theme of this week, extra credit, you write down, boom, the color for the markers today. Switch it up again. Triple extra credit, you're up to 3 different colors. See if you can name all 3 colors Bauer has used this week. All right, you got your power-up quiz here, guys. We're going to do these few examples on the back side. Please do them along with me as you write those. A says, please switch it to a percent. So I have 7/10. Now, there's a number of ways you can do this, guys. Fraction to percent. I know percent means out of 100. So what I did is I just multiplied by 10 over 10. That gives me 70 over 100, which is my percent of 70%. So I look at some of these and say, hey, I know how this works. 2/3, that's not 3 times, well, it gives me 100. I don't know how to do that. So what I'm doing with this one, I'm going to switch it to a decimal first by doing top in, bottom out. So I add my decimal and I get 3 goes in there 6 times, which is 8, gives me a 2, gives me a 6. It's going to go 6s forever, guys. I have another 18, it gives me a 2. Now, it started as a fraction, guys. I always end it as a fraction. Now, how do I switch a decimal to a fraction? It's right twice. So 1, 2, it's 66 and 2/3%. Now, hopefully, guys, that one's just memorized. And as we start to do this, you're going to do less work because it's going to be more memorization. In other words, in the future, I have to be able to look at 7/10 and say 70%. I have to be able to look at 2/3 and say 66 and 2/3%. But notice what I'm doing to get to percent. I actually switched this one to a decimal first, changed this fraction before I got there. Number 3 says, can you switch a decimal to a percent? Remember, right twice. So 1, got to add a 0, which equals 80%. Okay, so you just got through the 3 examples, guys. They never do that anymore. This is what your world's going to be. They're going to give you a box. They're going to give you one random one and then tell you to switch it to the other ones. So I have fractions, decimals, percents, and then I need to fill in the other ones. So I'm praying you got it memorized. You know 2/3 is 66 and 2/3%. You need to know that 1/3 is, first of all, 0.3. Repeating. You've got to have a bar above it. And then that is 33 and 1/3%. If I didn't know how to do that, top in, bottom out. The next one they give you is 1.5. I hope you know 0.5 is 1/2. Okay? So you can do this a number of ways, guys, if you don't know that. I like to do this percent first because it's, in my mind, the easiest. So right twice gives me 150%. Now I might be able to say, how do I switch that? Well, 150 over 100 might be the easiest way for you to switch it back to a fraction. Chop off the zeros, divide 10 into 15, goes once, got a 10, it's a 5, 1 and 5/10, and I know that reduces to 1 and 1/2. I would imagine many of you know 0.5 is 1/2, so you just didn't have to do anything. Okay, how do I do this one? I got 60%. Percent means out of 100, so the first thing I did is wrote 60 over 100. chop off a 0. 6/10. Now if I'm really good, guys, I stop right there and say 6/10. I know how to write 6/10 as a decimal. Choice 1. Choice 2. Boom, I know how to bounce left twice. 6/10 needs to be reduced down to 3/5. Okay, last but not least is 2 over 1, which is really 2. How do I switch 2 to a decimal? You don't, guys. 2 is a decimal. 2 is not a decimal number, so you just put the 2 there. You could put 2.0, guys, but 0.0, we just cross off the 0.0. So don't panic and say, Mr. Bauer, I need a decimal. There needs to be a decimal. No, there does not need to be a decimal, okay? So it's just 2. How do I switch it to a precise? Right twice. So it'd be like if there's a decimal point here, I have to add 2 zeros. So that's 200%. Okay? Guys, this is what they'll give you in the future. In fact, they'll give you this almost every day to the rest of the year. They'll give you one of those, a decimal, a percent, or a fraction, and we gotta switch it to the rest. So start to get comfortable with it, number 1. Start to memorize them, number 2. Okay, so if you're looking at the left and the right of me here, you can see how I have fraction decimal equivalents. They're really good. You can also look in the back of your yellow folder here, guys, as you're getting rolling with these. They give you some of the most common ones as you turn in just a couple pages. So you get to the back, where you have these computations, and you come in here. The only problem with it is it's kind of hard to see, but they give you about 10 common fraction decimal percents. Feel free to use that as you get rolling here. It's really nice. It's just the shaded part is a little bit hard to see, so you might have to do some squinting and some writing on top of it. All right, we'll see you for some problems. All right, 6, here we go with lesson 48. We're starting with number 2. It says write the prime factorization of that and that to reduce that fraction. Okay, we've done these for a while, so let's practice one of those things. I have 1,008, and I'm just going to break it down. Now, guys, I added 1 plus 8 and knew that 9 goes into it. So I have to do a little math in my head as I'm doing that. I'm really going to try to divide by 9 through here. So 9 goes into 10 once, 9 goes into 10 again, 9 goes into 18 2 times. Okay, now I want to break my 9 down to 3 and 3. I want to break this one down by dividing by 2. 2 goes into 11 5 times. 2 goes in 12, 56. Break that down to 7 and 8. Break my 8 down to 2 and 4. Break my 4 down to 2 and 2. Okay, across the top, I got 1, 2, 2, 3, 4, 2. So I got 1, 2, 3, 4. I have the 7. Oops, I forgot my 2 3s over there, and a 7. Okay, now I'm breaking down 1323, 1323. And once again, I added and I saw that it adds up to a 9, so I'm going to divide by 9. 9 goes into 13 once. 9 goes into 42 4 times. That's 36 is 63. It goes into 63 7 times. I break my 9 down to 3 and 3. I break 147. I added that together. That's 12, so I know 3 goes into that, guys. 3 goes into 14 4 times, and twice 7 9 times, and therefore I see this as a 7 and a 7. So now I'm going to go 3 3 3 7 7. Okay, now to reduce this thing, guys, I just start crossing. There's a 3 on top, a 3 on the bottom, a 3 on top, a 3 on the bottom, a 7 on top, a 7 on the bottom. What am I left with on the bottom? I'm left with a 3 and a 7. That's 21. What am I left with the top? 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, so that was prime factorization. They're giving us a huge fraction. Takes a lot of work to get that reduced down. Your other choice, guys, is you could have just started reducing. You think about just taking that big fraction and start reducing. It might have been faster just to divide both by 9 and divide both by 7 as we worked our way through that. Number 5. A 9-ounce can of peaches sells for $1.26. What's the unit price? So this was from Monday. I take my price, I divide it by the number of ounces. Decimal point straight up, goes in there 0 times, goes in there 1. That's a 9. Subtract is a 36, goes in there 4. My answer is 14 cents per ounce. That would be what would be written on the corner, left-hand corner normally of the price tag on the shelves. Number 7. Diagram the statement and answer the questions that follow. Van read 5/8 of the 336-page novel. So this is divide by my denominator, multiply by my numerator. So I have 336 divided by 8. Goes in there 4, it's a 32. 16 goes in there 2. Times it by 5. 5 times 2 is 10. Carry the 1, 210. So how many pages did he read? 210 pages. What does he have left? That's subtract. So 336 minus 210, 621. He still has 126 pages to go. Number 8, copy this figure, find the length of the unmarked sides, find the perimeter, dimensions are at the right. So we are getting these complex one guys that are not the same size as we work our way through it. So I got a 14 and I have a 24. I have a total height of 20 over here. I have an 8 here. I have a 12 on this inside, and I have a 6 over here. So I'm missing 2 sides. I'm missing side 1 here and side 2. I'm going to circle those so I don't think those are numbers to work with. First one, guys, I'm going to work with side 2. It's a horizontal. I know my total horizontal, and I know 2 out of the 3 pieces. So this literally looks like this has an addition problem. 6 plus whatever side 2 is plus 8 equals 24. Well, when you're missing something in addition like that, you add these two, 14, subtract it from the known, gives you a 10. So I know this guy is 10. Okay, I'm going to get my eraser going so that that doesn't confuse me anymore, and I got a 10. Okay, these vertical ones in my mind are the toughest ones. And it's going to look like this. The whole thing over here is 20. This piece of it is 12. So if I would take this side, I would divide it. Now, this is a little misleading, guys, but if I would drop a line here, if it's 12 on the left, it's 12 on the right. 12 plus what gives me 20? It's 8. If it's 8 on the right, then I go all the way over here and I get 8 on the left. 8 plus what gives me 14? That's a 6. If it's 6 on this left, I go over here and I get 6 on that right. Okay, so you got to be chopping those things. Now, what's wrong, guys, is I didn't draw it good, and so you're saying, Mr. Bauer, you wrote 8 on the bottom here, which is the correct answer. But look, it's longer than the 12. That's just bad drawing, guys. It's not bad math. The math is correct. Okay, I'm going to click my eraser, and I'm going to get rid of these numbers that might start to confuse me so that I can add up what I need to add up to get my answer. And now we're ready to solve this problem. Okay, so I got 14 plus 24. That's 38, 48, 58, 60, 70, 80, 86, 92, 100. So the perimeter is 100 centimeters. Whew, that's a problem, guys. That's an awesome one. Make sure you're learning the steps on that one as we work and continue to work into the future. That's just everything we have been working on all in there. Number 9. What percent of the family incomes is spent on other? Well, to figure out what the other is, guys, I have to add up everything else. So I have a 10%, I have a 12%, I have a 20%, I have a 25%, and I have another 20%. I add it up, I get a 7, 1, 2, 4, 6, 8, 80%. We know percents add up to 100, so I subtract, and I get a 13. 13% is spent on other. What fraction of the family income is spent on food? Well, this was the food one here at 20%, guys. So what they're doing is they're taking today's lesson and saying, can you switch a percent to fraction? Sure, put it over 100, chop it off, reduce it down. 2/10 reduces to 1/5. If 3,200 is spent on insurance, how much is spent on taxes? This is a proportion, guys. So I look at insurance and I say, insurance is 10%, that equals $3,200. Taxes is 20%. I don't know how much it is. Well, how did I get from 10 to 20? I times it by 2, didn't I? So times that by 2 and you got 0,046. Answer to C, $6,400 on taxes. Would this data be better displayed in a bar graph? Explain your answer. For me, the answer is no. Percents are always pie charts, guys. So just write percent is a pie chart. Okay, we're talking parts of a whole here. You got it. So A, B, C, D. Bumping down to number 14, today's lesson. They gave us the box, and they got it chopped up, and away we go. The first one they give me is 1/2. Guys, it's just memorized as 0.5. Right twice is 50%. Next one they give me is 0.1. Your teacher always gives you encouragement. Say it correctly. I say it as 1/10. That makes my fraction real easy to write. Right twice, 1, 2, gives me 10%. 3 gives me 25%. Left twice. Ding, ding is 0.25. Said correctly is 25 hundredths, so I can use either one of those guys to write down. Divide by 25 gives you 1/4. Hopefully that one's memorized as well, 4 quarters and a dollar. Last one is the number 4 over 1. 4 over 1 equals 4, which equals right twice, 400%. Number 15. The moped traveled 78 miles in 1 2/10 gallons gas. What did he average? Well, that was earlier this week. I'm just dividing. I have to slide it over once, so I have to add a 0. 12 goes into 78 6 times. That's 72. Subtract 6, 0. 12 goes into 65 times. He's averaging 65 miles per gallon. Boom. Flipping my answer key over. Number 16. Solve. I have 6 over 100 equals 15 over W. I don't see how I got there, so I'm just going to chop this in half. I have 3 over 50. Now I see 3 times 5 is 15, so 50 times 5 is 250. Turning my page in my math book. Number 20. It says 2 to the 5th power plus 1 to the 4th power plus 3 to the 3rd power. Do the math. 2 times 2 is 4, 8, 16, 32. 1 times 1 times 1 times 1 is still 1, guys. Don't write down 4. You'll get in trouble. 3 times 3 is 9 times 3 again is 27. Now I add them up. 2, 1, 7 is 10. Carry the 1. 1, 3 is 4. 5, 6, I got an answer of 60. So in my mind, guys, sometimes we sneak and say 1 to the 4th power is 4. No, 1 to the 4th power is always 1. That was number 20. Now we're up to 21. I can do 10 squared times 6 squared. Now, if you remember this, when we work this one, guys, we can break it apart. The square root of 10 squared times the square root of 6 squared. Remember, squares and square roots cancel out, guys. So I have 10 times 6 equals 60 again. Number 23, parentheses say do it first. So I have 4 minus 2/3. Cross out the 4, make it a 3, bring it over 3/3. 3/3 minus 2/3 is 1/3. 3 minus nothing is 3. Then I'm going to turn that around. I'm going to add it to 8 3/4. Common denominators are 12, so I took this times 3 over 3, that gave me 9. I took this times 4 over 4, that gave me 4 twelfths. Added them together, gave me 13 twelfths. That simplifies to 1 1/12. I carry that 1 up here, 9, 10, 11, 12. I have 12 1/12. 24, we have 15 over 16 times 24 over 25 times multiply 9 times 1 plus 1, 10 over 9. Here we go. I'm going to divide by 8, goes in there twice. Divide by 8, goes in there 3 times. Divide by 5, goes in there 5. Divide by 5, goes in there 3. 3 times 3 is 9. 2 times 5 is 10. I crossed everything out. Now, if I was doing it right, I would leave little ones back after I crossed everything out. So 1 times 1 times 1 times 1 is 1. Great problem where we eliminated everything. 25. Now we're doing division. I'm starting with parentheses, guys. 2 times 3 is 6 plus 2 is 8. So I have 8/3 divided by 4. I'm going to put 4 over 1. Remember, stays the same. Changes the multiplication. Flips over. Cancel. 4 goes in there once, goes in there twice. What do I have on the top? 2. What do I have on the bottom? 3. Now my new problem, 1 1/3. Multiply. 1 times 3 plus 1 is 4/3. Times. Flip. 3 over 2. Remember, you flip the second one, guys. Cancel the 3's. 2 goes into 4 2 times. My answer is 2. Great problem review of division. Number 28 says, students in the class were asked how many siblings they had and the students were tallied. If one student in the class is selected at random, what is the probability that the selected students would have more than one sibling? So guys, the first thing I have to do is count all those tally marks. So how many have 0 siblings? 3. How many have 1? 9. I'm going to write those down. How many have 2? 5. How many have 3? 2. How many have 4 or more? 1. I add those all up. 12, 17, 18, 19, 20. So there's a total of 20 students. The question was, how many, if you selected at random, would have more than one sibling? So 2, 3, or more. Add those together, I get an answer of 8. Have to reduce, divide by 4s. 8 divided by 4 is 2, 20 divided by 4 is 5. You'd have a 2/5 chance of picking that. 30, find the measure of ABC in the figure at the right. So they start down here with 50, guys. Always working with 180. 180 minus 50 is 130. That would give me the answer for C. This would be 130. This is a straight line, so 180 minus 130 would be back to this one. This one would be a 50. Now I'm inside a triangle. So I got 50 plus 90 is 140. Subtract that from 180 is 40. Up here would be a 40. So done correctly, guys, when you have A, B, C, you had 40 degrees, B would have been 50 degrees, and C would have been 130 degrees. Now that's going to bother us because a lot of us are going to say, I had to do letter A first because A comes first. Guys, you can't do A first. Some of us might have been tempted to say, if it's 50 down here, it's 50 up there. That's not true. These are vertical, they're equal. So supplementary lines, guys, of 180, and then inside a triangle for 180. Great problem teaching you. You don't have to go in order. You have to go with what they give you. All right, lesson 48. Have a great